know the shape. Remember, the quadratic function has to be presented in descending order because otherwise I can't identify what I need, always. So I see that the leading coefficient is 2, which is a number greater than 0. Therefore, I automatically know that the shape of the parabola is either opening upward or downward. Which one?
Upwards.
In other words, yes, it will have a minimum. So since a equals 2 and it's positive, this is the situation. Very good. When the leading coefficient is positive, the function has a minimum. Perfect. Number 2, I have to find the vertex. How do I find the vertex? Oh, no, no. It's too much work. It's not, it's, even if it's factorable, I would not. Because if I factor, I'm really solving the equation f of x equals 0, which has nothing to do with the vertex, unless the vertex is on the x-axis, but I don't know that yet. So how do we find the vertex? Anyone remembers what is the x-coordinate of the vertex? Say it again. Yes, correct, if the form is the completed square form, but it's not the completed square form. So you're right. So if we have f of x equals ax minus h squared plus k, yes, the x-coordinate is h, the y-coordinate is k. Perfect. But we don't have that here. And I don't recommend you start completing the square. First of all, because the leading coefficient is not 1, and it's a little bit more complicated. And we have not addressed those problems. We know how to complete the square only if the leading coefficient is 1. So it's a little bit more difficult. So I would not recommend you complete the square. So then? Awesome. Thank you, Shomi. Indeed. So this is negative b over 2a. If you remember, we compared that to the quadratic formula, and we said everything that is negative, except the square root. Everything that, if you remove the square root, you get negative b over 2a. That's the x-coordinate of the vertex. So minus is from the formula. B is 4. 2 times 2 is 4. So the x of the vertex is negative 1. Any questions so far on this? Let me know. Stop me if you have questions. Is this okay so far? Okay. How do we determine the y-coordinate of the vertex? For any function, if I'm given a function and I have x, how do I determine the y-coordinate? We don't have, plug it in, of course. This must be f of negative 1. There is no other way. Perfect. So this is 2 times negative 1 squared, which is 1, minus 4, minus 3. So 7 minus negative 7 plus 2 is negative 5. Very good. In step 3, I have to find the x-intercepts, if they exist. So let's analyze and realize or come up with an idea whether a decision, whether we should waste or not, should invest our time in finding the x-intercepts or not. So the parabola has a minimum. Look at the vertex and say, yes, find them, or no, don't waste your time, they don't exist. Yes. So the question now here is if I should find the x-intercepts. I should if they exist, but I wouldn't waste my time if they don't. So look at the vertex, look at the fact that there is a minimum, and decide right away, yes, go ahead and find them, or no, don't find them because they don't waste your time because they don't exist. Yes. How do I know? Awesome. Because the y-coordinate is minimum. Is negative, exactly. And the vertex, bless you, and the vertex is a minimum. Very good. Good. So now let's go ahead. How do I find the x-intercepts? What do I have to set? Awesome. Very good. F of x equals 0. So then 2x squared plus 4x minus 3 equals 0. Great. So now remember I have 4 options for quadratic equations. I have completed the square, never. I have taken square roots, not in this case. I can't take square roots because the square is not completed. and a quadratic formula and factoring. Which of these two you want to attempt? Quadratic formula, fine. So the quadratic formula quickly, negative b plus or minus the square root of b squared minus 4 times 2 times negative 3. So I'm going to change this into positive and multiply by 6, 2 times 3, over 2a, which is 4. You don't have to change the sign if you don't want to, but then you have to use a lot of parentheses, and I don't want you to think that you are adding instead of multiplying. And is this clear? Okay, so then 6 times 4 is 24. 24 plus 16 is 40, and I have to simplify it. Perfect. However, I was going to say, you're completely correct. However, because I have to plot, and I don't know what that square root will do, right? And I don't know exactly what the numbers are, I'm going to just approximate those two. So let's go to the graphing calculator and put parentheses around the numerator, negative 4 plus the square root. And in parentheses, again, I put parentheses. The calculator may not require them anymore, but so plus 24, close the parenthesis for the outside, and divide everything by 4. So this is, one solution is 0.58, let's say 0.6, and the other one, I have to change the plus into negative. And the other one is negative 2.6. So 0.6 roughly, and negative 2.6. Now, what are the ordered pairs that I have to plot that represent the x-intercepts? Can anyone give us the ordered pairs? Perfect. Perfect. And? Very good. Awesome. Perfect. Step number 4. Any questions? Y-intercept. How do we get the Y-intercept? Yes? Set? Perfect. Awesome. So f of 0, 0, 0, negative 3. What is the ordered pair? Awesome. Thank you very much. Great job, all of you. Good. So in number 5 and 6 and 7, range. We haven't even graphed it, but we already pictured the range. What is the range? So it has a minimum. The minimum value is very good, and it goes up. So the range is very good. Number 5, axis of symmetry. What is the axis of symmetry? The vertex tells us exactly what the axis of symmetry is. X equals negative 1. Very good. Awesome. X equals negative 1 is the axis of symmetry. And since it has a minimum value is definitely how much? Awesome. That's it. That's all we need. By the way, what is the domain of this function? Perfect. Because it's a quadratic, but the big umbrella is called polynomials. Perfect. So we're ready. Let's graph it. We start with the vertex, which is negative 1, negative 5. We continue with the axis of symmetry, which is a dotted line, not part of the graph. x equals -1. Very good. The x-intercepts, if this is 1, I'm going to say 0.6 is here. 1, 2, 3, 0.6 is here. And the y-intercept 0, -3. Okay? We know everything about this function, no secrets whatsoever. I'm going to try to make it as symmetric as possible. That's the role of this line. So one more time, we don't say here that we don't think in terms of symmetric odd or even. No. We are only stating that the parabola is symmetric with respect to its own axis of symmetry. It has nothing to do with odd even. It could be. So we can have a situation like this in which we've graphed this function so many times. So this is x squared. X squared is symmetric with respect to the y-axis, so it's an even function. And it also happens to have the axis of symmetry x equals 0. But that's a different story. But here we are only saying that this function is symmetric with respect to its own axis of symmetry. Is this better? Very good. Other questions? Is there anything else you worked on? Anything you would like to ask? Yes, Chris, you had a question? Okay. Anything else? Anyone? Before we move on? So I don't want to forget, we need to finish this problem, number 60 on page 351. So I'm looking back at what we covered last time. And we had f of x equals -0.8x squared plus 3.2x plus 6. I'm copying from the previous lecture notes. X is the horizontal distance. And this is the vertical height. I shouldn't put vertical. If it's height, it's very clear. Okay. So we determine the vertex of this parabola to be 2, 9.2. That was done last time. And now we are asked to find the x-intercepts in part B, x-intercepts. How do I find the x-intercepts for this function? What do I have to write? Awesome. F of x equals 0. So then I -0.8 x squared plus 3.2 x plus 6 equals 0. Okay, what do you recommend we should do here? Say it again, divide by? Awesome. That's the first thing I have to do, of course, to make it as easy as possible. So it's indeed 0.8x squared minus 3.2x minus 6 equals 0. Remember, that's my recommendation. It's not mandatory. It's up to you. But my recommendation is, and I will never personally solve a quadratic equation with a negative leading coefficient. That's not going to happen. So then we use the quadratic formula. I agree. So negative b plus or minus b squared minus 4ac. I put plus because this is negative. So times 0.8 and times 6 divided by 2 times a. You can put two negatives in there, but you have to be careful and put parentheses and not change the product into something else. So I'll go back to the graphing calculator and punch them in. I will put parentheses around the top and parentheses under the square root. So let's go back to y equals. So parentheses. And I have 3.2 plus the square root. I put parentheses again, 3.2 squared. And then plus 24 times 0.8. Close the parenthesis under the square root, go outside and close the parenthesis and divide by 1.6. And that would be 1 horizontal distance or x-intercept. Now the other, let's see if it makes sense with the negative. So this one doesn't make sense. It's behind the y-axis. So x equals 5.39 feet, and x equals negative 1.39 feet. So that cannot be the maximum distance covered by, horizontal maximum distance covered by the, I don't remember what it was, a ball or, and in part C, let me look what we were asked in part C. I don't know, I have to look it up. So 60 on page 351. Let's see, do you remember what part C was? 354, 351, yeah, okay. 351. It's not.
What was the shock release? That's part C.
So it's not. Oh, 361. I'm sorry, I wrote 351. Sorry about that. It's 361. Okay. What was it?
Graph the function that models the balls.
Which we already did. That was 60, right? Graph the function that models the, yes. So let's look at this again. Here it is. So this is 2 feet. From this point till this point, it's 5.39. The maximum horizontal distance before it hits the ground. So from the launching site till this point, 5.39 feet. Good. Other questions for me? Other questions for me? Okay. So you can stop me anytime if you remember something. Joseph, any questions? Okay. So let's look at 3.2. Polynomial functions of higher degree. By higher degree, we mean degree 3, 4, 5, 6, and so on and so forth. You have till Sunday evening to finish up everything for test 1. Everything. I'm going to close it up. We're moving forward. Okay? So till Sunday night, everything that we had for test 1. Test 1. I'm not talking about test 2. I'm talking about test 1.
That's everything on the 3IO?
Everything that we had for test 1, including 2.5. That has to be completely done. We are moving forward. Otherwise, I have to put zeros. So please, all quizzes, homework, fast prep, everything done for test 1 that we finished 2 weeks ago. Okay? Till Sunday night. Please. I want to. Yes, this Sunday. Yes. 5, 6 days from today. Yes, till midnight. Beyond that, okay, I have to push everyone forward for test 2 now. And we have to finish that. Okay? And please remember, I'm kindly asking you, I posted solutions. I have to check. But I scanned everything, and if not, I'm going to post it in the next few minutes after we finish. So please print out the solutions, check line by line, and redo all tests. This one, the second one when we finish it, and the third one from now on till the final exam every weekend. Then before the final, you're just going to briefly review, and you're going to be ready for the final. If you wait till the last moment, you're going to have difficulties because the material is piling up. So please do that for me, please. Okay, so we're going to start with degree 3 and so on and so forth. But first, I would like to go back for a moment to quadratic, just to list what we just looked at, those 7 items. You don't have to write them one more time, but I'd recommend you do. So the first one was the shape, then the vertex, the X-intercepts, if they exist, the Y-intercept, axis of symmetry minimum, because I want to say a few things here. So number 1, we have shape. In number 2, the vertex. In number 3, X-intercepts, of course, if they exist. In number 4, we have Y-intercept. In number 5, we have axis of symmetry. In number 6, we have max min. And in number 7, we have range. This is what we looked at. And you can say, okay, what about domain? Yeah, I'm going to say domain also. I didn't emphasize it because we already knew that quadratic functions are defined everywhere. And this will continue. Now, for higher degree, the list is much bigger. This, when we talk about vertex, we only talk about one function, and that function is quadratic. So never again. So there is no vertex for anything else, just for the quadratic function. Of course, X-intercepts, the Y-intercept, yes. There is no axis of symmetry for any other polynomial function. Not. Max min, yes. Range and domain, yes. But there are other items that we did not have in quadratic. So please remember, vertex is only for one function. Axis of symmetry, only for one function, which in both cases, quadratic. No other function has an axis of symmetry. No other function has a vertex. Okay. So what do we have here for higher degree? The list is longer than 7. So in number 1, we can have shape. We don't discuss shape for higher degree. So I'm going to start with the domain. Number 2, degree. Some of these items can be made into one, but I just want to present the whole list just once. 3, max number of terms. By terms, we mean max and min. That's what we mean by terms. Max or min. Number 4. I would need to insert a word in here. It's maximum possible number of terms. So the point I'm making is the function doesn't have to turn that many times. So the maximum possible number of turns. End behavior. End behavior. This we did not have for quadratic. Number 5. Max min with TI. I'm going to write 84 because that's what I have, but you can use 81 through 86. Number 6, symmetry. I don't mean the axis of symmetry. There is no such thing. By symmetry, you mean an odd or an what type of function?
Even.
Yes. Number 7, multiplicities. Oh, 8. I need the X-intercepts first. X-intercepts. And then the next one, multiplicities of X-intercepts. I will explain what that means in a minute.
So don't, okay.
Sorry about that. I jumped ahead. X-intercepts, multiplicities of the X-intercepts. That's why we need to find them first. Number 9, range. Like with everything new, you already know I talk a lot. It takes me a long time to present the first sample, the first example, but then the next one will take 2 minutes, the next one will take 1 minute. But the first one will take a long time, maybe 10 minutes. So please bear with me. Before we graph or we select a polynomial function of higher degree, 3, 4, 5, and 6, I want to mention 2 things. Number 1, if you know how to graph a third degree, you will have 0 difficulty with degree 5 or 7 or 9. If you know and you understand how to graph a fourth degree, you will have no difficulties with degree 6 and 8 and 10 and so on and so forth. We're not going to go that far. So we're not going to look at higher degree than 6. So if you know 4, you know 6. If you understand 4, actually if you understand the quadratic function, you understand 4 and 6. If you know how to graph the linear function, you will have no difficulties with 3 and 5. But again, the first example will take a long time. Okay, number 2, item that I was going to mention. I need to talk about multiplicities before we start working on our first polynomial of higher degree. So here's the scenario, multiplicities. You've heard me say something about this, but I didn't mention the word. So some time ago, we did talk about it. Multiplicities of X-Intercepts, or also called zeros of f of x. X-intercept or zeros of f of x, we mean the same thing. Okay, so let's look at a few graphs so that I can explain multiplicities. And you will remember when I graph the first 2, you will remember what I'm getting at. So let's say I have a graph, I have a function, and it crosses, I'm going to say 0.1, 0.2, 0.3, 0.4, 0.5. X equals 1. So let's say at x equals 1, a particular function does this. I have another function. Let's say at x equals 2, this function, a different function, does this. Can you remember a function that does this somewhere that we graphed over and over and we used before in chapter 2? Can anyone remind us of what this function? Similar? Awesome. Do you remember what I said? How many solutions are there in x cubed? Well, 3. And how much are they? 0. But there are 3. Okay. So let's suppose a different function at x equals 3 does this. And let's suppose I have a different function that at x equals 5 does this. Okay, so for this function, obviously it crosses at x equals 1. How many times do you think we have this solution x equals 1? Exactly, that's once. We call this multiplicity 1. For x equals 1 appears once. There is no connection between this number and this number. But because it appears once, we call the multiplicity is 1 for this solution. Let's take a look at this one. Let's say this is x equals 2. How many times do you think x equals 2 will be found as an x-intercept? Exactly. So 3 times. So what is the multiplicity of x equals 2 for this second function? Excellent. Okay. So I just asked you before and you gave me the answer, so now you forgot. Okay. That's okay. So let's suppose we have f of x equals x cubed, correct? X cubed equals 0. How many solutions will you give? Okay. And they all are? Exactly. So that's why the graph of x cubed is not this. That would be incorrect. The graph of x cubed is this. It doesn't mean that the graph or the function crosses at the origin 3 times. It only means that it takes its time. It crosses at 0 once, but slowly. Does not do this. So when we have an odd multiplicity, the function will cross, but it depends how. If a solution appears once, it will cross fast. If a solution, it's odd, right? If a solution has multiplicity 3, it will take its time. What if it has 5? It will be even slower. It will be something like this. Slower. One cross, but even slower than this. Because there are x equals 6, 5 solutions there. Same number. Okay, so odd multiplicities will tell us from the start that the function will cross the x-axis. Now, what do you think this type of multiplicity is it? What is this? Of course, it's an even multiplicity. What about this one? We already know this one. It's like x squared. How many solutions will that be? Well, it's going to be negative x plus minus 3 squared. How many solutions do you think this one has here? What is the multiplicity of x equals 3 for this function? Say it again. You want me to repeat the question?
No, I got you. I don't say two.
Exactly. It's quadratic. So x equals 3 will appear twice. What do you think about x equals 5 for this function? How many times does it? See, they're different. This one it turns quickly, but this one takes its time. So how many solutions x equals 5 do you think this function has? It cannot be odd because it doesn't cross. 4. So this has multiplicity 4. So if it turns, the multiplicity has to be even. If it crosses, the multiplicity must be odd. Well, the other way around, basically, because once I find the x-intercepts of a polynomial function and I find that x equals 5 appears twice, I know it's a turn. If I have that x equals 3 times, I know it's a cross and it's a slow cross.
Wait, so say it again. If it turns, it's even?
So if the multiplicity, it's basically the other way around. If the multiplicity is even, it has to turn. If the multiplicity is odd, it has to cross.
Why is there nothing at 4?
Shit. I can say it.
Because I didn't graph a function for you. You want me to graph a function at x equals 4? I can.
If it crosses.
Let me write it. We are going to learn this in a minute with examples, but if you want to summarize it, we can summarize it. So multiplicity, odd and even. Okay?
Easy for you.
Odd multiplicity, it's a cross. Even multiplicity is a turn. Now, if the multiplicity is 1, it's a regular cross. Just simple cross. Simple cross. If the multiplicity is 3, what will happen there? It's going to be a slow cross. Even is a turn. If the multiplicity is 2, what will happen there? Like x squared, quick turn. What if the multiplicity is 4? What will happen? A very slow turn. Very good. That's it. So this is in summary. If you go higher, it's going to be slower. Slower cross or even slower turn. That's all it means. So let's look at our first example. Let's try, yes, Joseph, go ahead.
I missed all of them.
I'm sorry?
I definitely missed all of them.
That's okay. You were thinking about something else.
No.
No, not to worry. We're going to have plenty of examples in a minute.
To the graph. There.
Okay, so let's start with 53 on page 378. So this is f of x equals 3x squared minus x cubed. Okay, so for the first problem, as I said, it will take longer. I'm going to list all these items, but then from problem 2, 3, and so on and so forth, we're going to put everything and summarize everything in a table. So we're not going to have to write everything again. Okay, so for this, I'm going to go through domain. What is it? Perfect, because it's a polynomial function. So the question is asking us to graph it. Number 2, and I may combine 1 or 2 items together. So what is the degree? Yes, indeed. Maximum possible number of turns. Let me tell you how to find that. I didn't say it yet. Max possible number of turns is degree minus 1. So in this case, it will be perfect. Number 3. X-intercepts. How do we get the x-intercepts for any function? Very good.
Yes.
Oh, everything is the same like with the quadratic. We didn't do anything. Really, nothing new so far. Good. So what do I have to do next?
Do 3,
In descending order,
yeah.
of course.
So would it be minus x cubed plus x squared?
Very good. Awesome. Let's write on the side how many solutions.
3.
Exactly. If the degree is 3, there must be 3 solutions. Good. So how do I solve this? We've done this in chapter 3. That's why in chapter 2, that's why we did it. No, actually in chapter 1. What type of equation is it and how do I solve it? We had this on test 1. Way more complicated than this one. What type of equation is it? Of course, polynomial. We're talking about polynomial functions, right? Good. It's a polynomial function. I refuse to solve an equation with a negative leading coefficient. Very good. Now what? What will you say? Do this. What is that? What am I going to do?
Take out x squared,
Awesome, of course. What is left in parentheses?
x minus 3.
Good. Thank you for studying. I'm really seeing that. I appreciate it. Thank you. You make me very happy. I need 3 solutions, please. Exactly. Very good. 0 and x equals 3. What is the multiplicity of solution x equals 0? Very good. What is the multiplicity of solution x equals 3? 1. So the multiplicity, when I add them up, I have to get 3 solutions. When I add 2 plus 1, do I get 3 solutions? Perfect.
Wait.
So what would be the ordered pairs here? Pause.
I think it's 0. Yeah, I need 0. So
X times x minus 3. When x is 0, I get 0. When x is 0, I get 0. When x minus 3 is 0, I get x equals 3. Chapter 1. Section 1.5 or 1.6, I don't remember.
would it be 0, 0,
X minus 3 is 0. I move negative 3 to the other side, and I get x equals 3. Yes?
So are we saying here, n is equal to the very multiple the x, 2x is equal to 0?
Exactly. That's all it means.
So the multiplicity is 2 because 0 comes up twice?
Exactly. That's all it means. That's what I said. Be patient. You're going to get there slowly. So we have 0, 0, and we have 1, 0. 0, 0, and 3, 0. Say it again.
No.
Is this okay? Everyone? Okay. Moving on. Number 4, Y-intercept. Can anyone give us the Y-intercept, and how do I find it?
you substitute
Very good. X equals 0, f of 0 is 0. We already have it. Number 5. Let's talk about end behavior. We have not seen this before. The end behavior refers to where the function is going when x approaches infinity or negative infinity. Is it this? That's one option. Is it this? That's another option. Is it this? That's a third option. Or is it this? There are only 4 options. So one more time, what was the degree of this function? 3. Any odd degree has to behave like the linear function. Either this situation from negative infinity to infinity, or this situation from infinity to negative infinity. What is the slope of this line? What type of slope? Correct. The leading coefficient is positive. What type of slope is this? That's exactly the same behavior for any polynomial odd degree. So now I go back and I look at the leading coefficient. That's why we should have rearranged it from the very beginning. What is the leading coefficient of this? Negative. So it behaves exactly like a linear function with a negative slope from positive infinity to negative infinity. So that's the end behavior. That's all it means. If it's this, which is not the case, or this, nothing else can happen for an odd degree. It has to behave like the linear function when it comes to end behavior. Okay, 6.
So how
Negative.
From positive infinity to negative infinity because the leading coefficient is negative.
So that's the answer.
We are going to summarize all the information in the table in a minute. I'm just listing them just one time,
Okay.
just for this problem, according to the list that we created. Say it again. So let's see what we accomplished so far. Domain, yes. Degree, max number of terms, yes. End behavior, yes. Max, min, I have to wait with the graphing calculator. Then symmetry, in a minute. X-intercepts done. Multiplicity of the X-intercepts done. And the range after I graph. So the only thing that I have left is the symmetry. And this talks about f of negative x, right? As we know. So I go back to the function and replace x by negative x. That's what we did this in chapter 2. And also I should write the negative f of x right here. Negative f of x is x cubed minus 3x squared. So negative x to the third power. Negative x to the third power is 3 negatives. What is the sign? Negative x to the third times negative 1 in front. Positive x to the third. Perfect. Negative x squared. X squared, very good, times positive 3. Excellent. Very good. So now we have 3 questions, right? Does this equal the original function, which was negative x cubed plus 3x squared? Does this equal the negative f of x, which is x cubed minus 3x squared? Or none of the above? Does this equal that? No, so it's not even. Does this equal this? No, so it's not odd. It happens that this function is not symmetric. It would have been nice, but it's not. We have to mention that. It's one of the items. Okay, so now let's create a table that we will be using moving forward. And let me show you what I put in the table, and everything will be summarized. It will be very easy to graph the function. So I go back to all the work. First, I put in the domain, negative infinity, infinity. That's the domain. Then look at number 5. I have the end behavior from positive infinity to negative infinity. Positive infinity to negative infinity. I have 0, 0. And I make myself a note, don't forget the function turns there. I have 1, 0, which is a regular cross. Nothing fantastic happens there. And I don't have anything else. This is it. And symmetry, none. No symmetry. This is it. You can find more points if you want to. There is no need. So after you summarize all the information, and as I said, moving forward, we are going to summarize it like this. We're not going to write 3 pages of work unless you want to. That's fine. So let's attempt the graph. Ready? So let's try to understand this information and then come up with a graph together. Let me see if I passed. No, I didn't. That's fine. First, I have to plot 0, 0. Then I will have to plot 1, 0. It wasn't 1. Why am I writing 1 all the time? It's 3. It's 3, 0. Sorry about that. I meant 3. So 1, 2, 3. Okay. So let's look at our table and make sense of the information we have. The function is coming from positive infinity, coming down to the origin where it turns, which is a regular turn, not a slow turn. From positive infinity, it turns at 0. From positive infinity, it comes to the origin and turns. Something must happen here because all these functions are continuous, smooth functions. So something must happen here because it comes up, it has to continue and cross at 3, 0. So it has to have a maximum somewhere. And then it crosses at 3, 0 according to my note, and it's going to negative infinity. And that's it. This is the graph of f of x, negative x cubed plus 3x squared. One thing that I wasn't able to determine is this maximum. So there is obviously a local max here. And I'm going to put it in the table and on the graph. Now with the graphing calculator, let's put it in. Be very careful how you put it in. It has to be in parentheses. No, I'm sorry. It's not a product. Sorry. So it's x cubed minus 3x squared. Now let's think a little bit about the viewing window. We already graphed the function. So it turns at 0. So I don't really need too much of the negative side of the x-axis. It crosses at 3. So I'll say I'm going to go up to 5 or 6. So from negative 2 to positive 5. So I'm going to the window. So let's say from negative 2, that's good enough, to positive 5, that's good enough with a scale of 1. And then I already have the graph, so it turns at the origin and then crosses. So I don't really need to see too much of the negative side. So let's see the positive side. I don't know. I'm going to say 10 for now with a scale of 1. And then hit graph. Here it comes. I forgot the negative sign. Sorry about that. Let's insert the negative. And it was positive here, right? Yes, it was positive. What was our function? Yes, negative plus 3x squared. Sorry about that. So it's plus. Okay, let's try again. So it's coming from positive values and positive infinity, turns at the origin as expected and crosses at 3. The only thing that I don't have, and I cannot determine it in algebra without the calculator, we can with my next class, we determine these max min without the calculator, but not in algebra. So in order to determine this value, this height, we will have to go to second and calc. We're trying to find the maximum. It's a local maximum. The calculator is asking me, where do you want me to find it? Well, I'm going to ask the calculator to find it between x equals 1 and let's say x equals 4. So I'm going to say 1 is the left bound. it puts a limitation there, and then I'm going to say 4 is the right bound. So yes, between this and this value of x, just give me the maximum. I don't want to guess, just press enter again, and it gives us the maximum as 2, 4. So I go back to my table. I will put 2, 4 as the local max, and 2, 4 as the local max. As I said, the first problem took us a while. Let me see, I don't want to go over 50.